NEC Article 220.6 provides guidance on the requirements for single-phase circuits derived from a three-phase 120/240-volt service. This article is essential for understanding how to properly calculate and design these circuits to ensure safety and compliance with the National Electrical Code. When working with single-phase circuits originating from a three-phase service, it is crucial to adhere to the specifications outlined in NEC Article 220.6 to prevent overloading, voltage imbalances, and other potential hazards. The article addresses various aspects including feeder and service calculations, load balancing, and conductor sizing. Calculating the load for single-phase circuits from a three-phase service involves several steps. Firstly, determine the total connected load for each phase. This includes all lighting, receptacles, and appliances connected to each phase. Secondly, apply any applicable demand factors as permitted by the NEC. Demand factors allow you to reduce the calculated load based on the likelihood that all connected loads will not be operating simultaneously. Thirdly, balance the load across all three phases as evenly as possible. This helps to minimize voltage imbalances and ensures efficient operation of the electrical system. Fourthly, calculate the neutral conductor size based on the unbalanced load. The neutral conductor must be sized to carry the maximum current that could flow through it under normal operating conditions. Fifthly, select the appropriate overcurrent protection devices, such as circuit breakers or fuses, to protect the conductors from overloads and short circuits. These devices must be sized in accordance with the ampacity of the conductors they are protecting. Sixthly, ensure that all wiring and equipment are properly grounded to provide a path for fault current to flow back to the source, minimizing the risk of electric shock. Understanding the specifics of NEC Article 220.6 is paramount for any electrical professional working with three-phase services and single-phase circuits. This article provides the necessary guidance to ensure safe and compliant electrical installations. When designing single-phase circuits from a three-phase 120/240-volt service, you must consider the neutral conductor requirements. The neutral conductor carries the unbalanced current between the phases. The NEC provides specific rules for sizing the neutral conductor based on the type of load and the potential for harmonic currents. In many cases, the neutral conductor must be sized the same as the phase conductors. However, in some situations, it may be permissible to reduce the size of the neutral conductor. It is important to consult the NEC to determine the appropriate size for the neutral conductor in each specific application. Load balancing is another critical aspect of designing single-phase circuits from a three-phase service. An unbalanced load can cause voltage imbalances, which can lead to overheating of equipment and reduced efficiency. To minimize voltage imbalances, it is essential to distribute the load as evenly as possible across all three phases. This can be achieved by carefully planning the placement of lighting, receptacles, and appliances on each phase. When adding new single-phase circuits to an existing three-phase service, it is important to consider the impact on the overall load. The total load in the service must not exceed the capacity of the service entrance conductors or the main overcurrent protection device. If the addition of new circuits would cause the service to be overloaded, it may be necessary to upgrade the service to a larger size. The NEC provides methods for calculating the service load and determining the appropriate size for the service entrance conductors and overcurrent protection device. Understanding these methods is essential for ensuring the safety and reliability of the electrical system. In addition to load calculations, the NEC also contains requirements for the wiring methods used for single-phase circuits from a three-phase service. These requirements cover aspects such as conductor type, conduit type, and grounding. It is important to select wiring methods that are appropriate for the specific application and that comply with all applicable code requirements. For example, in wet locations, it may be necessary to use waterproof wiring and equipment. Similarly, in hazardous locations, it may be necessary to use explosion-proof wiring and equipment. The NEC also contains requirements for the installation of receptacles and lighting fixtures on single-phase circuits. These requirements cover aspects such as receptacle spacing, grounding, and GFCI protection. It is important to install receptacles and lighting fixtures in accordance with all applicable code requirements to ensure safety and functionality. GFCI protection is required in many locations, such as bathrooms, kitchens, and outdoor areas. GFCI receptacles and circuit breakers are designed to detect ground faults and interrupt the circuit, reducing the risk of electric shock. The NEC also contains requirements for the identification of conductors on single-phase circuits. The grounded conductor, or neutral, must be identified by a white or grey color. The ungrounded conductor, or hot, must be identified by a black, red, or blue color. Proper identification of conductors is essential for safety and troubleshooting. When working with electrical systems, it is important to always follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses. It also includes de-energizing circuits before working on them and verifying that they are de-energized using a voltage tester. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. NEC Article 220.6 is a critical resource for electrical professionals designing and installing single-phase circuits from 3-phase 120/240 volt services. A thorough understanding of this article, combined with adherence to safe work practices, is essential for ensuring the safety and reliability of electrical systems. The information in NEC Article 220.6 is regularly updated to reflect changes in technology and best practices. It is essential to stay current with the latest edition of the NEC and any applicable local amendments. Continuing education courses and professional development opportunities can help electrical professionals stay up to date on the latest code requirements. Understanding the concepts within NEC Article 220.6 also requires a foundational knowledge of electrical theory. Concepts such as voltage, current, resistance, and power factor are essential for performing accurate load calculations and designing safe and efficient circuits. Furthermore, a familiarity with electrical symbols and diagrams is necessary for interpreting electrical plans and specifications. The proper application of NEC Article 220.6 also relies on accurate measurements. Using calibrated instruments to measure voltage, current, and resistance is crucial for verifying the performance of electrical circuits and troubleshooting problems. It is also important to understand the limitations of measuring instruments and to use them properly. Troubleshooting single-phase circuits derived from 3-phase services often involves identifying the root cause of problems such as overloads, short circuits, and ground faults. A systematic approach to troubleshooting, combined with the use of appropriate test equipment, can help to quickly identify and resolve these issues. Understanding the operation of common electrical components such as circuit breakers, transformers, and motors is also essential for effective troubleshooting. When performing electrical work, it is important to document all changes and modifications made to the electrical system. This documentation should include detailed wiring diagrams, load calculations, and equipment specifications. Accurate documentation is essential for future maintenance and troubleshooting. It is also important to comply with all applicable permitting and inspection requirements. Many jurisdictions require electrical work to be inspected by a qualified electrical inspector to ensure compliance with the NEC and local codes. NEC Article 220.6 also touches on energy efficiency considerations. Designing circuits with energy-efficient lighting, appliances, and controls can help to reduce energy consumption and lower utility bills. The NEC contains provisions for the use of energy-efficient equipment and for the design of energy-efficient lighting systems. Understanding these provisions can help electrical professionals to design and install electrical systems that are both safe and energy efficient. In addition to the technical aspects of NEC Article 220.6, it is also important to consider the ethical implications of electrical work. Electrical professionals have a responsibility to protect the safety and welfare of the public by ensuring that electrical systems are designed and installed in accordance with all applicable codes and standards. Ethical conduct also includes honesty, integrity, and fairness in all dealings with clients, colleagues, and the public. The knowledge gained from NEC Article 220.6 should be applied with a strong sense of professional responsibility. Consider the long-term implications of design choices and always prioritize safety and reliability. The application of Article 220.6 is not just about meeting the minimum requirements of the code, but also about striving to create electrical systems that are robust, efficient, and sustainable. This involves a commitment to continuous learning and a willingness to embrace new technologies and best practices. Finally, remember that NEC Article 220.6 is just one part of our comprehensive set of electrical codes and standards. It is important to have a broad understanding of the NEC as a whole and to be familiar with other relevant articles and sections. A thorough understanding of the NEC is essential for anyone working in the electrical industry.